January 7th or 8th, I opened my PC and checked the mail. And one of the mail says, you are winner of King Faisal Prize. So that is the first thing I noticed this prize. So because this King Faisal Prize is very famous worldwide, so everybody knows it. So hey, that's me. So I was really grateful, of course. So then I ring up my friends. I got this one. So that's the beginning. So okay, carbon nanotube was discovered in 1991, but actually this is very accidental, the discovery. However, if I think of this discovery without my long experience with the scientific technique, without this technique, I cannot find carbon nanotube. That technique is electron microscopy. Electron microscopy is to see the very small structure, even a single atom and molecule. These days we can see directly this. So I was involved in this sort of scientific community and tried to see how small one we can see through the electron microscope. So I looked through the many nano structures, the mineral, the semiconducting material, the metals, and carbon, the many different type of carbons. And so carbon nanotube is one of the material I experienced in my long history. So this is accidentally, but without this, the experience, I don't think no one can find carbon nanotube. The carbon is like a charcoal, see, and the candle soot. It's nothing. It's lavish material that no one put the interest in. But before the discovery of carbon nanotube, there was a similar structure was discovered by a British chemist. That was 1985. The carbon nanotube discovered 91. So six years later, I found carbon nanotube. So before that, they found the carbon, the fluorine molecule. So they are very similar, consist of carbon atoms, and the structure is also similar. So I have knowledge of this, and I had also some connection with Harry Kroto in Sussex, UK. So before I discovered carbon nanotube, already we had some kind of communication about Harry Kroto's C60 molecule. So because I have done some work on this similar material. So before carbon nanotube, we exchanged some the knowledge about the fluorine. And actually, it's the Harry Kroto pursued me to do the work on the carbon material. That's the beginning. I started to look at the carbon material similar to C60, and then I looked through the many different kind of carbon material, carbon structure. Charcoal and everything, graphite. Then one of them, that was carbon nanotube. So when I saw it, it's a nanotube. It's very elongated structure. That's already unusual. Carbon, the fluorine is a spherical soccer ball type structure, but this one is elongated. Okay, so immediately I saw this one. Hey, look at this one. This is something strange, something new in the science because it's unusual structure. So that was the beginning of discovery of carbon nanotube. The silicon is the semiconductor. okay, so that we can make a transistor. But carbon nanotube is the conventional, the carbon material is metal, so not semiconductor. But the carbon nanotube becomes the semiconductor. This is already very unusual. All carbon are conductor, but when you have this very tiny, the cylindrical tubular structure, it becomes the semiconductor, like silicon. So it's similar. The technology, they can make identical transistor, many on the silicon wafer. But carbon nanotube, we cannot do this now, because we can make a very super duper transistor, just a single transistor, okay? But that's good. But for the commercial application, you need millions of identical structures. That's the silicon technology. But carbon nanotube is getting close to this kind of engineering. But at the moment, it belongs to the sort of basic science, physics, okay? But once they talk about application, you have to go to the engineering. As I said, you have to million exactly identical structure you should produce. But we cannot do with carbon nanotube so far. Now in the silicon technology, you're talking about the 2 nanometer or 10 nanometer chip, because it's getting smaller and smaller. So if you make the very small tip, okay, so your energy consumption is extremely decreased. Carbon nanotube can do it. Okay, if you want to make the transistor from the silicon, the process, making process is very complicated and expensive. But carbon nanotube is very simple structure. It's just arranged because already it's very small structure. So if you can, and also I said. 2 nanometer the channel length, so we can make a very small transistor, and then also we can have the big current through this carbon nanotube. So this can be competitive to the silicon technology. So this is very simple application. This is the bulb, okay? So I switched on here. So this is a light bulb, and it used to be used for the light bulb, okay? So here I have the carbon nanotube inside, and the carbon nanotube emits a lot of electrons, okay? So electron hits the fluorescent screen, like a fluorescent light. So similarly, we can use this one for the illumination, light source. And that was nearly 20 years ago. And many industrial people are excited about this application. Okay, this is the big one. You can make it millimeter size lamp, and you can make an array of this lamp, so that you can have the TV screen. Actually, Samsung or the Japanese electronics companies, they try to use this one as the display. Okay. But in that industrial application, there are many other ways to do it. So carbon nanotube display defeated by other material, LED, and the organic, the semiconducting material. So it disappeared completely now. Yes, still one group working on, maybe a few groups working on this application. Not simple light bulb. They use the principle to the X-ray generation. Okay, so if you go to the medical doctor, you have the chest film, and they use the X-ray. So it's a conventional way to produce X-ray. But if you use the carbon nanotube, you can make a very, very small X-ray camera, okay? So and also, yes, this American, the professor, already they produced the application of carbon nanotube using the X-ray emission. Okay, if you go to the airport, your luggage will be checked. Okay, to put in your luggage. So that's what they detected by X-ray. So you have the X-ray, but the you can have the this kind of carbon nanotube X-ray source. So the very small and energy consumption the very little small. So economically very efficient. X-ray the luggage detector can be already this was built, and some airport used them. So this is very visible practical application. So that's interesting. Also, if you go to dentist, they use the X-ray. So this carbon nanotube X-ray go around your face and then take the 3D images using X-ray from the carbon nanotube. Actually, my lab did some experiment. Okay, if you carbon nanotube, and then you can load some the cancer the medicine on the small carbon nanotube surface, and then they put them in the bloodline, and then they catch your liver or whatever where you have cancer. Then they are attached to this the disease, the organ. So then after that we shine the light, okay, so special light. This is what we call the infrared light. Infrared light penetrates your body, okay. So after injecting the carbon nanotube with the medicine, then shine and they heat it. Then the medicine will be released and attack the cancer cell. So this kind of what they call the DDS, drug delivery system. So there are many different types of these drug carriers, but one of them is carbon nanotube. Still, people are working on this. In my long career, I worked on the mineral, which is planted in Earth, right? So this is one of the material I was looking for, the new things in mineralogy. Then the metallurgy, the semiconducting material. So in that way, I explored the different areas and come to the carbon material, where I come across the carbon nanotube. Something new, unknown structure. Maybe we want to know what property, the chemical, physical properties. Okay, so started to check what it is, and then very recently, still I found a new finding here. So this is a carbon nanotube. Okay, just black, not interesting at all. But this one made of carbon nanotube, and furthermore, then here I have a flashlight, okay, and then switched on. Okay, then it shines the light. Maybe you cannot hear sound from here and in some distance, but if you're close to here, yes. It makes sound. There are some basic physics in this phenomena. Okay, actually, I discovered two years ago, but unfortunately, already this was reported by the American physicist. He was the Graham Bell. You know Graham Bell, the inventor of telephone.
Yeah.
So he discovered this phenomena 1881. 150 years ago, he noticed this phenomena, but so then this is my sort of the rediscovery of Graham Bell, but because now I'm talking about the nanomaterial, Okay, so in the Graham Bell time, there are no nano words. Okay, so no electron microscope. But this is the kind of the basic science. Okay, if I show you this sound, because if I demonstrate this to the kids, maybe they started to twinkle their eyes because they are very curious about this. What happened to this? Okay, that's the start of science, like a basic science. So at this moment, I don't know, it makes sound, that's it. But could be used for some useful application in our life. So that's the what I'm interested. I want to do. Okay. So discovery is yeah. Some of them started from that point. So I like to do this. So this is very small things, but still, I'm very interested in this kind. When I found carbon nanotube, other people are doing the nano something. Okay, nano is the interesting area because before that there's no such word, the word nano. Okay, so then discovery carbon nanotube kind of switched on the nano science, nanotechnology. So nano is unknown word. So that's my sort of contribution. Okay, so I don't need to do everything by myself. So then they stimulated in that way. So they started their own area. So that influence is very important. Okay, so I'm proud of this because maybe I switched on the nano science, nanotechnology by discovering carbon nanotube. Invention is like the silicon transistor. The silicon becomes the semiconducting material.
Yeah.
That is discovery of the semiconducting properties in the silicon. So this is entirely the basic physics. Okay, so then silicon becomes the semiconducting. So then after that, people try to use this silicon as the transistor. So that's the discovery and later on that invention. So it's slightly different.
Yeah.
Okay. To me, there's no recipe how to do discovery. Okay. And so I said I did this. Many things I tried. Then accidentally I found sort of the shining diamond in the garbage. Okay, so the carbon nanotube. So you should do many things, but all of it's sort of rubbish. But occasionally you can find the good diamond. So the discovery carbon nanotube, and this is very tiny bits. Okay, so we cannot make a million of the chip, semiconductor chips, but then we need plenty of a lot of material, and that's been done by the lithium battery people. Now carbon nanotube is used for the lithium battery. It's as electrode. So they need a massive amount of carbon nanotube. So, but this we know all basic the knowledge how to produce carbon nanotube, what type of carbon nanotube should be produced. We know all this knowledge now. So industrial people utilize this knowledge, and then they make a ton of material, and then they're making some business. So I think the carbon nanotube depends on what you want to do. So if you want to make the semiconductor chip, that is we should use another approach, not like the application to the lithium batteries. It's rather sophisticated and this well-controlled structure of carbon nanotube they needed for the semiconductor application. So many people are working on how to make the what you want to do. So the producing this or quantity or quality. If you go to the semiconducting area, you have to have the very pure, well-controlled structure. They need it. If you go to construction work, you see a very strong light. This is the carbon, the arc, the welding. Okay, so arc welding, you see some smokes. Okay, those are nanomaterial, nano oxide of the iron. Okay, principle is exactly the same. I use carbon dot and then do the arc discharge. So this contact area get very high temperature. So even the carbon is a high temperature material. Okay, don't melt. But if you do the arc discharge, even the carbon evaporate, then that decrystallize. Evaporating is carbon atoms. They combine again. And if you control it, then some special structures form. And that was same as the hydrochlorotos, fullerene. Fullerene is also prepared like that. So this is first the way to produce carbon nanotube, and later on, soon after, we can also use the laser beam, like carbon surface hits the laser light, and then the heating area get hot, and the carbon evaporate. Then they decrystallize, evaporate. Gas is formed, carbon. And then for the massive the amount of carbon nanotube, they use the like hydrocarbon material, methane, the acetylene into the oven. Then in the gas, what do you call it? Gas phase chemical reaction. Okay. So then we need some the catalyst, the metal catalyst. So in that way, we can make a lot of carbon nanotube.